Okay, good day class. So welcome to our session for today. So this time we are going to have the topic geotechnical hazards. As for our learning objectives, at the end of this session, you will be able to number 1, define geotechnical hazards, and then describe the nature of geotechnical hazards, explain mechanisms, the triggering mechanisms of geotechnical hazards, and then also summarize methodologies and processes on risk assessment that will be introduced in a short while. So hazards under this context are accounted as geotechnical in nature. So these are earthquakes and liquefaction, landslide and other slope movements, differential settlements and subsidence, bridge and foundation scour. So ground-related hazards such as earthquakes and landslide have often resulted in catastrophic disasters worldwide, destroying urban areas and causing great economic losses. We can see here in the slide an example. So this is actually a landslide event somewhere in 1999 wherein the Cherry Hills subdivision has a landslide event wherein it collapsed several houses. Okay. And then another example, we have here the 2018 Itogon Benguet landslides. It was triggered by the Typhoon Ompong brought by heavy rains and strong winds in northern Luzon. So the casualties is around 58. So by the way, this landslide event is characterized by bank houses, and the communities are miners, that is why some of them have had notioned that this event is triggered by the mining activities. However, the DNR attested that it was not about the mining activities but the soil characteristics as well as the heavy monsoon, and of course the geomorphological characteristics in which the site is steep. It's characterized by a steep slope. Okay, so in short, the land use is residential on this slopey terrain. Okay, so another example is we have here 2012 Compostela Valley debris flow. So it was triggered by heavy monsoon, Typhoon Pablo in 2012. It caused massive debris flow in Barangay Andap. So it is a flow of mud, boulders, and gravel rushed towards the community. So the casualties is around 128, including 450 missing on that event. So aside from the landslide, we also have the earthquakes. So based on the earthquake records, about 2,000 occurrences average per year, so that is a huge amount, but only 12% are actually felt. So if we are going to compute that, 12% of 2,000 is 240. still a considerable number, okay, when it comes to earthquake. And with this number, 5 to 6 are very strong with damages. So as an example, we have here an earthquake occurrence in BOHOL in 2013. Okay, so the magnitude is 7.2 with a casualty of 222, which includes 796 injured, and the damage to properties peg up to 2.25 billion, okay, worth of damages to public buildings, roads, bridges, flood control projects. So it was reported in Bohol and Cebu. And a total of 671,000 families, or that is around more than 3.2 million people were affected by the earthquake, So by far, it is the most casualties and damages occurred in Bohol. So you can see here in the data, it actually includes several residential houses. So with the number, referring to the number, it is around 71,900 residential houses were actually damaged. Okay, and 14,480 were totally destroyed. So you can see here in the picture, meron tayong destroyed houses in Loon, and we also have Town Hall of Tubigon, then the houses in Tubigon also, and destroyed church in Clarin, and then destroyed home in Katigbian, and ground rupture. So here, okay, so that event is actually a catastrophic one. So why is that? It seems that our country is a favorite destination for these hazardous events, because Philippines is home to 300 volcanoes. So 1,500 is the number of active volcanoes around the world, and 75% of it is within the Ring of Fire. That is why 90% of world's earthquakes are found in the Ring of Fire. So being situated on the Pacific Ring of Fire, and well within the broad path of seasonal typhoons, the Philippines is really particularly prone to disaster caused by ground-related phenomena, so earthquakes or rainfall-induced slow failures. Okay, so these are perennial problems, especially in mountainous areas. So dito sa atin, we are mountainous areas. We belong to mountainous areas. So the Ring of Fire is roughly around 40,233 kilometer chain of volcanoes and seismically active sites around the Pacific Ocean. So sabi nga, 1,500 yung active volcanoes around the world, and the Pacific Ring of Fire is home to 75% of that number. Okay. So Philippines lies along the Pacific Ring of Fire. That causes the country to have frequent seismic and volcanic activity. So here we can see in the slide the earthquakes and fault lines in the Philippines based on 2014 data by Philbox. So the country, which has a land area of 300,000 square kilometer, that is smaller than California, has not just one but 5 major fault lines. So these fault systems are known as Western Philippine Fault, Eastern Philippine Fault, South Mindanao Fault, Central Philippine Fault, Marikina, or Valley Fault. So isang fault lang yan, but they are interconnected. So there are major fault lines. So the red dots here are NEIC seismicity, or what we call National Earthquake Information Center seismicity. So it refers actually to the magnitude. So the smallest red dots are magnitudes less than 7.0. Okay? So kung titignan natin, tad-tad yan ng red lines or red dots. So the largest dot is around 8.5 to 9.0. Okay? So again, tad-tad pa rin yan. Napakaraming earthquake occurring in a year. Okay. And then the dotted lines are fault lines offshore. Yung dotted lines dito. Okay. So offshore meaning it is not within the land. Okay. And then the solid lines are well located faults. And then the broken lines are approximately located fault lines. So these are maps that is being digitized. Okay. And then the pink lines are the subduction zones. So remember yung subduction zones, wherein one of the tectonic plates are subducted, meaning it is inserted beneath the other continental plates. So in short, it can be viewed that Eurasian plate and the Philippine Sea plate is subducted to the Philippine island. Ayan o, yung Eurasian plate tsaka yung Philippine Sea plate is actually subducted to our country. So hazard definition and classification. A hazard is a set of conditions in the products or systems operation that may be potentially initiate an accident. So let us highlight here the term potentially, okay, and the set of conditions. So from this definition, it can be said that a hazard event is a failure event associated with a particular hazard. Incorporating the term accident in the definition is important since it implies human involvement in the consequences. Okay? In short, before na maging hazard yan, there should be human that is being affected by those events. We are therefore operating on the boundaries between technical explanation and society. So natural hazards are unexpected or uncontrollable natural events of unusual magnitude that threatens the activities of people or people themselves. So natural events, these are events such as earthquakes, volcanic eruptions, and floods happen regardless of whether or not people are exposed to them. So events pa lang yan. So it is when they affect people that they become natural hazards. So once these events will affect the community or people, it will be termed as natural hazards. So magiging hazards na. Moreover, A natural hazard event resulting in widespread destruction of property or causing injury or deaths is called a natural disaster. So, natural disaster, let us highlight here the term widespread destruction. Okay, so widespread destruction or property. So, catastrophic hazards are hazards that have devastating consequences to huge number of people or have a worldwide effect, such as impacts with large space objects, huge volcanic eruptions, worldwide disease epidemics, worldwide droughts. So such catastrophic hazards only have a small chance of occurring but can have devastating results if they do occur. So remember that hazards can be occurring or non-occurring. So we highlight a while ago the term uh, potential. Okay, so potential pa lang yan. Kaya nga tinawag na hazard. It is a potential harm. Okay, so unlike dito naman sa disaster, so this is the effect of the natural hazards. An effect which is a widespread destruction. Okay. And then catastrophic, malaki yung damages that this hazard hazard will have a potential effect on people. And then rapid onset hazards. These are hazards which develop with little warning and strike rapidly. So, as an example, volcanic eruptions, earthquakes. Yung earthquakes kasi mahirap na i-predict yan, as well as the volcanic eruptions. Like in the recent Taal eruption. And then we also have flash floods, landslides, severe thunderstorms, lightning, and wildfires. So hazards could also be classified as slow onset, wherein these are hazards that would take years to develop, like drought, insect infestations, and disease epidemics. So we also have anthropogenic hazards. These are hazards that occur as a result of human interaction with the environment. So they include technological hazards, which occur due to exposure to hazardous substances such as radon, mercury, asbestos fibers, and coal dust. They also include other hazards that have formed only through human interaction, such as acid rain and contamination of the atmosphere or surface waters with harmful substances, as well as the potential for human destruction of the ozone layer and potential global warming. So we also have the classification of hazards and disasters. Geologic hazards is one of the several types of adverse geologic conditions capable of causing damage or loss of property and life. These hazards consist of sudden phenomena and slow phenomena. So examples: tsunami, volcanic eruptions, landslides, floods, subsidence, impacts with space objects. And then atmospheric hazards, where the causal factors is atmospheric process. So we have the tropical cyclones, tornadoes, droughts, severe thunderstorms, lightning. So other natural hazards. These are hazards that may occur naturally but don't fall in to either of the categories mentioned, they will not be considered to any great extent in this course but include insect infestations, disease epidemics, and wildfires. So what will be the effects of hazards? So it could be direct or indirect effect. So the direct effect is actually the primary effect, and the indirect effect will be the secondary and the tertiary effect. So the primary effects occur as a result of the process itself. For example, water damage during a flood or collapse of buildings during an earthquake, landslide, or hurricane. For the secondary effects occur only because a primary effect has caused them. For example, fires ignited as a result of earthquakes, disruption of electrical power and water service as a result of an earthquake, flood, or hurricane, or flooding caused by a landslide into a lake or river. And then the tertiary effects are long-term effects that are set off as a result of primary event, and this includes things like loss of habitat caused by a flood, permanent changes in the position of river channel caused by flood, crop failure caused by a volcanic eruption. So how to deal with hazards? So remember that hazards events are defined as the action of an earth process to cause an adverse effect on human activity. So in dealing with these so-called geotechnical hazards, we may take the limits to be those processes directly affecting the ground. So these hazards are generally caused by natural processes such as earthquake and rain-induced slope failures. Sometimes, human activity can trigger a cutting into hillside for housing development, may initiate landslide due to steepening of slope. So ito yung tinatawag na disturbances. And then we also have continuous pumping of fluid from aquifers. So too much extraction ng mga resources underneath, iubusin mo yon. So what will be the effect? It may result in local or regional ground subsidence. So lulubog yan. And remember that we have the control and the elimination. Okay? So kung talagang ayaw nating maapektuhan, how can we control it? So we civil engineers and you as a future one have a great role dito, no? In terms of a well-designed engineering interventions, kung well-designed, economical and resilient. So in short, it will serve on its purpose. So aside from that, hindi naman lahat kaya nating daanin sa engineering measures because sometimes it could be impractical, ano? So if we could not control it, we could eliminate it by assessment and mapping. So by mapping, we could predict and we could forecast the future events and how is the severity of these disasters happening. So proper understanding and scientific having a well-established scientific basis could be of a great factor in dealing with hazards. So what will be the hazards in the modern times? So seemingly we have an increasing number of media reports regarding the occurrences of volcanic eruptions, earthquake, floods, and other natural events. However, these processes have been occurring on Earth for several billion years. And why do we hear more about them now? Because we have more population that are being exposed to those hazards. And then we also have better communication technologies and greater interdependence among countries. So with this, we have an increased level of awareness, and we also have an increased media reports. So yun nga lang, people are becoming more exposed because of the increased population, better communication technologies. We also have the increased level of awareness. Nadoble yan. And then the improved interdependence between countries has sharpened the impact of natural disasters. So how is this? Kasi nga, interdependence, meaning this is something about the supply chain. Kung yung isang country producers ng isang raw material for a lot of countries, may interdependence. Like for example, a certain earthquake in 1999, the GEGEO earthquake in Taiwan, affected the sales of personal computers in the United States because the earthquake brought a 2-week halt to computer chip manufacturing. So, nung lumindol sa Taiwan, naapektuhan din yung mga companies in US na nag-assemble ng or nagmamanufacture ng computer chip because ayun nga, na-disrupt yung supply chain production in Taiwan. So on a larger scale, the whole world is anxious over what might happen to the global economy if and when a large-scale earthquake occurs in Tokyo, which is an important international business center. So alam naman natin yung Japan, very prone yan sa earthquake. Yun, kinakabahan yung mga countries that are dependent to them. Okay? So that is the improved interdependence between countries. And then we also have the improved forecasting and mapping. So the scientific basis and education with regards to natural hazards are so important to have an efficient and effective forecasting and mapping. That is to reduce or eliminate the effects, okay, or the risk brought by the natural hazards. So the nature of geotechnical hazards is illustrated on the framework flash on the slide. We have predisposition, the trigger mechanism, and the effect. So predisposition meaning is a tendency to happen, or what we call the proneness or the susceptibility. So most geotechnical hazards are part of a complex chain of cause and effect. So the immediate cause is trigger mechanism. For example, an increase in pore water pressure may trigger a landslide. So it weakens the slope material with the increased pore water pressure. Other underlying factors defined in predisposition, proneness or susceptibility. Yung predisposition na tinatawag is proneness or susceptibility. So these factors may be very complex, as in the case of landslide. Example is shown in the cause and effect figure 1.1 below. So, ano bang ibig sabihin yan? Ibig sabihin, there are a lot of things to consider with respect to study of geological hazards. Okay? So, we can see here that the triggering factor could be the material strength loss, erosion, the pore water pressure, soil swelling, pore pressure decrease. So, pore pressure decrease will have an effect, ground subsidence. The swelling of soil will have the ground heave. Pore water pressure, of course, landslides. Erosion is also attributed to landslide. Okay? So, kung saan-saan nakakonect yan, that is why you cannot just easily deal with this phenomena. There is no one-size-fits-all solution. Okay? Baka pag sinabi mo, basta clay, tapos 60 degrees, magko-collapse yan. So, hindi ganon. So, there are a lot of things to consider. Like the environmental change, the volcanism, tectonism, and then the environmental change will cause climatic conditions na magkakos ng drought. So, bababa yung groundwater. It will have a pressure decrease. So, lulubog yung lupa. And then, precipitation, because of climatic conditions, tataas yung rainfall. And then, it will have an infiltration. Of course, a groundwater rise will cause soil swelling and pore water pressure. And then from precipitation, it will also cause surface runoff that will cause erosion that will trigger a landslide. And then temperature also have been a factor. Of course, we have studied that temperature is a factor for weathering process, which will have a material strength loss effect. And then the tectonism, volcanism will have the seismicity, will have material strength loss that would trigger a landslide also. Okay? And structural subsidence or loss of bearing capacity. So, ganito kakomplikado ang geotechnical hazards. So, we also have here framework wherein the boundaries between geotechnical technology and socio-economic activity. So, in reality, it is difficult and sometimes impossible to draw clear distinctions, particularly when disasters are viewed over a longer period. There is often a sequence of interlinked connections, blurring the divisions between predisposition and trigger, as we can see on the illustration. So, materials and site characteristics, trigger mechanisms. These are affected by weathering, geotechnical parameters, sequence, geologic structure, geomorphic structure, and the human influence. Okay? So, sa engineering design, it could be a solution or remediation sa mismong hazards, or it is not already economically feasible, you can prevent it. Okay? Then that could be supported by monitoring, because from monitoring we can generate important data that could be a good basis in the engineering design. Okay. So the nature of geotechnical hazards. Part of the nature of geotechnical hazards is their uncertainty and unpredictability in terms of one or more of the following: the mechanism, magnitude, frequency, timing, location, and severity of consequences. So such situations tend themselves to statistical method, which when combined with deterministic process mechanics result in a powerful methodology for coping with geotechnical hazards in the society level. So hazard is often quantified in general terms as the probability of an event occurring, like probability of seismic ground movement event above a specified magnitude. Events are sometimes catastrophic, like seismic hazards, but other may be slow, such as hazard related to ground subsidence or tinatawag nating liquefaction. So the effects may be immediate, cumulative, or threshold controlled. So we go now to vulnerability. It is a measure of the degree of damage or loss that would be expected from a particular event. So this can be expressed totally in economic terms, like repair costs, insurance loss. However, some losses like life or curtailment of some human activity are less easy to quantify. So vulnerability is, to a large extent, within human control by design or avoidance, but we may be unprepared to accept the cost. Vulnerability is a complex issue involving engineering design of structures, construction material, quality, and aspects of human decision making. So it refers the way a hazard or a disaster will affect human life and property. Vulnerability to a given hazard depends on, so it is dependent on the following, proximity to a possible hazardous event. So when we say proximity, for example, meron tayong fault lines. So kung malapit ka sa main fault line, yun yung proximity, meaning the possibility is that the probability is that high. And then the population density in the area proximal to the event. Of course, it refers to the number. So kung walang tao dun malapit sa Taal volcano, then walang vulnerability. And then the scientific understanding of the hazards. So if you are aware na may active volcano pala doon, so that is about the scientific understanding of the hazard. And you know that in a coastline, you are prone to tsunami events. Then, hindi ka you will not have the courage to live there on the vulnerable areas. And then we also have public education and awareness of the hazards, existing or non-existence of early warning systems, and lines of communication. So nowadays, usong-uso tong early warning systems as well as mapping. Okay. And then the availability and readiness of emergency infrastructure. So these are the support of the government wherein there are facilities na pwedeng takbuhan in case of emergency cases. So construction styles and building codes. Of course, it will be the design is derived from a scientific basis. And then the cultural factors that influence public response to warnings. So, maraming ang nagsasabi or maraming nagsishare na scientist na umalis na kayo dyan. But because of the culture, sasabihin ng mga society or the community, hindi naman nangyari yan within how many years. But take note, we are actually subjected now to climate change, which has brought several changes in precipitation patterns as well as geologic events. That is why ito, malaking factor yan, okay, in reducing hazards. So, moving on to the risk. Risk is the potential for economic loss and can be expressed for individual locations, whole communities, or even wider areas. So, risk is actually the product of hazards times vulnerability. So, it is actually affected by two parameters. So, number one is the location. And then we have also the exposure. So, location refers to site-specific conditions and indicates where buildings and other structures are being constructed. So, long ago, the risk of seismic hazards was small because people tended to build structures on good soil. However, yun nga, nagsisiksikan na sa urban areas, kahit saan na pwedeng gumawa ng bahay, no? So, nagiging risk na yun. And then we also have exposure. Refers to the number of people exposed to hazards. There used to be few structures, but the number has been quickly increasing. For example, by 2008, an estimated 75% of US population will be living 16 kilometers off a coast, and therefore most Americans will be at risk from natural hazards. So kung noon, wala pang bahay sa mga island, now that is being occupied because of the increasing population. Of course, the more people exposed, that is actually a parameter of exposure. So for better understanding, let us have this slide wherein it compares the hazard versus risk. So hazard as actually something that can potentially cause harm. Ano ba yung mag-harm sa'yo? Yung pating. Walang risk pag wala ka dun, of course. So there will be a risk if you are going to swim with the shark. Okay? So hazards plus exposure is actually the risk. A hazard is something that has the potential to harm you, pero hindi ka pa na-harm. But if you're going to swim on that vulnerable area, then you have the risk, the likelihood of a hazard causing harm. Here is an example of the level of risk. So, kapag 5, that is likely to occur. Pag 4, possibly to occur, unlikely to occur. If we have 3, 2, we have rare, and number 1 is very rare. Okay, this is just an example of risk level. So, assessing hazard and risk. Hazard assessment consists of determining the following: when and where the hazardous processes have occurred in the past, the severity of the physical effects of past hazardous processes, it refers to magnitude. And then the frequency of occurrence of hazardous processes. Ano ba? Every 5 months, every 2 months, every month. Then the likely effects of a process of a given magnitude if it were to occur now. And making all this information available in a form useful to planners and public officials responsible for making decisions in an event for disasters. So risk assessment involves not only the assessment of hazards from a scientific point of view, but also the socio-economic impacts of hazardous event. By the way, hazard assessment is different versus that of the risk assessment. Yung hazard assessment it refers to hazard event to occur. Ano ba, bagyo ba ngayon? Lilindol ba bukas? So that is hazard assessment. But when we have a risk assessment, it is the combination of the hazard and the socio-economic impact. So kapag umulan bang bukas, ilan yung mamamatay, ilan yung possible potential na casualty and loss and damages to properties. So that is actually the risk assessment. It is a statement of probability that an event will cause the amount of damage or a statement of economic impact in terms of monetary. Okay. Risk assessment involves hazard assessment as above. We have location of buildings, highways, and other infrastructure in the areas subject to hazards. So, pag nag-assess ka, syempre, asan ba yung mga vulnerable, yung mga building, highways, and then the potential exposure to the physical effects of hazardous situation. And we also have the vulnerability of the community when subjected to physical effects of this event and the decisions in event of a disaster. So, as a matter of treatment also, risk and vulnerability can sometimes be reduced if there is an adequate means of predicting a hazardous event. So, prediction involves a statement of probability that an event will occur based on scientific observation. Such observation usually involves monitoring of the process in order to identify some kind of precursor events, so meaning an anomalous small physical change that may be known to lead to a more devastating event. Examples: hurricanes are known to pass through several stages of development. We have the tropical depression, tropical storm, and it will develop to hurricane. So once a tropical depression is identified, monitoring allows meteorologists to predict how long the development will take and the eventual path of the storm. And then we also have volcanic eruptions are usually preceded by a sudden increase in the number of earthquakes immediately below the volcano and changes in the chemical composition of the gases emitted from a volcanic vent. So if these are closely monitored, volcanic eruptions can be often be predicted with reasonable accuracy. Forecasting. Sometimes the word forecast is used synonymously with prediction and other times it is not. In the prediction of floods, hurricanes, and other weather-related phenomena, the word forecast refers to to short-term prediction in terms of the magnitude, location, date, and time of an event. Most of us are familiar with weather forecasts. So in the prediction of earthquakes, the word forecast is used in a much less precise way, referring to a long-term probability that is not specific in terms of the exact time that the event will occur. Example nga, yung earthquake, Pag nag-forecast ka, it is within a period. Like, prior to the October 1989 Loma Prieta earthquake, also known as the World Series earthquake, the U.S. Geological Survey had forecast a 50% probability that a large earthquake would occur in this area within the next 30 years. So, hindi mo alam kung 20th year ba, sa 10th year ba mag-occur yun, and the chance is 50% lang. Even after the event, the current forecast is for a 63% probability that a major earthquake will occur in this area in the next 3 years. So, these are the examples. Like yung predict nila na yung the big one in NCR, yung West Valley Fault, pag gumalaw yun, ang laki ng damage because sabi nila, tapos na yung every 300 years, yung every 300 years, it is within this period. Pero, we do not know kung bukas yon sa makalawa or next month. Okay? So, meaning, it is actually unpredictable. So, early warning. A warning is a statement that a high probability of hazardous event will occur based on a prediction of or forecast. If a warning is issued, it should be taken as a statement that normal routines of life should be altered to deal with the danger imposed by imminent event. So nowadays, yung Pag-asa as well as Philbox has their early warning. So it signals the community what to do. In fact, local governments are also having some evacuation centers as a measure to reduce the danger, okay, by the imminent event. So the effectiveness of a warning depends on first, the timeliness of the warning. Of course, kapag late na yan, hindi na magiging early. Okay? So effective communications and public information systems to inform the public of the imminent danger. So importante dito, of course, meron na tayong internet available and communication technologies. Importante pa rin yung signals, Okay. So the credibility of the sources from which the warning came. So hindi naman maganda kung warning tayo ng warning and then false alarm pala. Okay. That is why the forecast or the early warning should be credible. So now we proceed to the trigger mechanisms of these geotechnical hazards. So first, the climatic events. Of course, we know that the occurrence is very often annual cycle or many occasions per year. Of course, bilang na natin sa Pilipinas, And then we also have seasonally related. So a good example, continuous rainfall will weaken the slope material in mountainous area, causing landslide occurrence. So this is very true in our region wherein yung mga heavy precipitation will cause landslides. So another trigger mechanisms is the magnitude frequency relationship. Of course, kung malakas tapos laging nag-o-occur, there will be an implied vulnerability of the hazards that may occur. Okay, so most applicable in earthquakes, storm, rainfall, and floods. So it defines the rate at which we may expect events releasing a certain amount of energy to occur, or what we call the return period concept. So example of return period. So magnitude 8 to 8.9 earthquakes has an average occurrence of twice a year, or a magnitude 4 to 4.9 occurred 15,000 times per year. So those are magnitude frequency relationship. So yung mga malalakas, nag-occur lang yan twice a year. At yung mga mahinang earthquake, nag-occur yan napakaraming beses. So return period is not analogous to design life, but rather it uses the probability of occurrence and exposure to risk to increase the design reliability of the structure. So actually, return period is being integrated in the National Structural Code of the Philippines, particularly designing a structure that is an earthquake resistant. So another trigger mechanisms is progressive change. So example is progressive change in soil strength due to weathering can lead to landslide. Of course, weathering weakens the material. So the time of failure reflects the rate of change of the controlling parameters. Progressive change shall be anticipated to be considered in the design calculations. Progressive changes go some way towards explaining why a trigger of a certain magnitude might not cause an event in 1 year but a later date. A similar magnitude might occur. So it can be rapid in some systems or slow to other systems. Then we have here environmental change. So the most important aspects of environmental change are long-term climate changes and human influence, climatic change, and the ways human activities may influence it. Evidences have shown some cyclicity in the patterns of climatic indicators, so engineers should consider these trends and account them in planning and design. So human influences resulting in environmental changes other than climate are also numerous. So examples are oil, water, and gas abstraction cause decline in pore water pressure. Pore water pressure rise in areas of rising groundwater or leakages from water pipes and drains. Ground warming in permafrost areas due to human interference. And we also have the mining-induced subsidence and seismicity. Actually, we have been a contributor in this environmental change. So, pore water pressure is important in stability. So, what is pore water pressure all about? So, remember when you build a sandcastle, you need to to fill in a certain amount of water, pero wag mong sosobrahan kasi magigiba yung sandcastle mo. So the principle there on the pore water pressure is that meron siyang surface tension, and this surface tension will fill the void spaces or the gap between the soil particles, wag lang sobra. So the principle of surface tension is a thin film on water surface. Kung meron tayong water surface, subukan mo maglagay ng blade doon, and the blade won't sink kung pahiga, because there is a slight tensile force on the surface. So kapag yung water is within the soil particles just enough to have negative pore water pressure, it will hold the soil material and contribute to its strength. Okay, so high pore water pressure tends to weaken the soil or rocks, so this will cause instability kung sobra yung tubig. Now, to summarize, triggering mechanisms may be direct or underlying, as discussed in the framework a while ago. So they often display strong magnitude-frequency relationships suited for statistical analysis. So the controlling mechanisms may not be static. They may be subject to changes occurring in a wider climatic environment, natural or human influence. Human activities can substantially modify the magnitude-frequency relationship and induce new trends in long factors. There is a need to understand this complexity in the controlling environment to appreciate the difficulties in identifying and monitoring geological hazards. So, this ends our lecture on geotechnical hazards. So, on our next, we will go on the details. So the next discussion will go on the details about some methodologies, instrumentation, and procedures to deal with these mentioned hazards. So with this, thank you for listening, and see you on the next video session. Have a good day, class.